In this video, we are going to go over the application of differentiation. And the first question, given that y is equal to x cubed minus x squared minus x plus 1, find the stationary points. Now, when you want to find the stationary points, what you need to know is that when we have got a graph, whenever we've got a point like this, the gradient is always equal to 0. And the line which goes up, for such a line, the gradient is equal to infinity. Now for a line which goes like this, the gradient is positive, and a line which goes like that, the gradient is negative. Now for stationary points, these points we can see that they are flat. Therefore the gradient of the stationary points is equal to 0. And if you differentiate, the derivative is called the gradient function. Therefore what you get, you equate it to 0. You're going to find the stationary points. So for the first one, we are going to differentiate dy over dx is going to be equal to 3x squared minus 2x minus 1. So that is it. Now we're going to equate this to 0. So dy over dx, the gradient is equal to 0. Therefore 3x squared minus 2x minus 1 should be equal to 0. So from here, the product of this function is negative 3 if we get to multiply this and that, and the sum is a negative 2. So which two numbers can we multiply to get negative 3? If we add them, we get negative 2. So let's consider 3 and a 1. Negative 3 and a positive 1. So those are the factors. So we're going to put here 3x squared minus 3x plus x minus 1 is equal to 0. So I'll factorize out the first two. I'll remove the 3x. We'll remain with x minus 1 and then plus 1. X minus 1 is equal to 0. So this will give us 3x plus 1, x minus 1 being equal to 0, giving us that x is equal to negative 1 over 3, or x is equal to 1. Okay, so these are the x values of the stationary points, but what are the y values? So we start when x is equal to 1. What will be the value for y? We'll go in the actual equation. So y is going to be equal to 1 to the power 3 minus 1 to the power 2 minus 1 plus 1. This is a 1, 1 minus 1 is a 0. And then, okay, this is a 1 positive, this is negative. Negative, positive. So all of them are going to cancel out. Because this positive will cancel out with this negative cancels out with the positive. Therefore, y is going to be equal to 0. So for the turning points, I'm going to write the coordinates. The first coordinate to the turning point is 1, 0. Now, what of when x is equal to, that's negative 1 over 3, what will be the value for y? So y is going to be equal to negative 1 over 3 to the power 3 minus negative 1 over 3 to the power 2 minus negative 1 over 3 plus a 1. And here y is going to give us negative raised to the power 3 is to be negative. 1 to the power 3 is still 1. But 3 raised to the power 3, that is going to give us a 27. Negative here raised to the power 2 is going to become positive, and negative times positive will be negative. 1 to the power 2 is 1, 3 to the power 2 is a 9, and then it's negative with a negative there, that is going to give us a positive. So we're going to have positive 1 over 3 and then plus a 1. So from here, to be able to find the y value, let me make all the values to have 1 or the same denominator. So that is negative 1 over 27. How can we make 9 as a 27? We know that if we get to multiply 9 by 3, we get a 27. So I'm going to multiply on top and down by a 3. So I'm going to have negative 3 over 27. Then plus, how can we make a 3? A 27. We know that if we multiply by 9, we're going to have a 27. So multiply by 9 on top and also down by 9. And then plus, we know that 1 is the same as 27 divided by 27. Now that the denominator is the same, I'll simply write that in the denominator 27, then add what is on top, negative 1 minus 3 plus 9 plus 27. So that is going to give us y being equal to negative 1 minus 3, that is a negative 4. Negative 4 plus 9, that is the same as 9 minus 4, that is a 5. And then 5 plus 27, that is a 32. So this is 32 divided by 27. So we have seen that when x is equal to negative 1 over 3, our y value is 32 divided by 27. So these are the turning points. Alright, now let's consider the second part. State the nature of the stationary points. Now, to state the nature, we want to understand, is it the maximum or the minimum, or it is a point of inflection. So we can use two ways. One way we can use is finding the second derivative, although it is limited, where if we find the second derivative is giving us a 0. So the 2y over dx2, that is going to be equal to, firstly, let me first differentiate the first one. When we found dy over dx, we found that the answer was the 3x squared minus 2x minus 1. Now we are again differentiating this one, so that will be d2y over dx2, and that will give us 6x minus a 2. Okay, like that. Now we are going to get our x coordinates. So the first one, when x is equal to 1, let's get to substitute here. What will be d2y over dx2? d2y over dx2 is going to be equal to, let's put a 1 here, that will be just a 6, and then 6 minus 2, that is a 4. And whenever d2y over dx2 is positive, then this is a minimum. And when x is equal to negative 1 over 3, which is this other point, let's see what d2y over dx2 will give us. d2y over dx2 is going to be, let's put negative 1 over 3 here, so it is going to be 6 multiplied by negative 1 over 3 minus a 2. So 3 can go there 2 times, so remain with negative 2 minus 2, which is a negative 4. Whenever you find that it is negative, then that is a maximum. But when you find 0, the 2y over dx2, when you substitute, it gives you 0. Then you need to use the second method, which is the tabular method, to determine, because it can also be a point of inflection when the second derivative is giving you 0. Now let's get to use the second one we determine. So what we've just seen is that the first point here is the minimum, and then the second one is the maximum. So when you are using the second table, that is, you just use the second derivative, dy over dx. Let me write it at the end. Dy over dx, that is equal to 3x squared minus 2x minus 1. So for this one, we're going to get the 2 points when x is equal to 1. So I'll get when x is equal to 1. And then I'll put the 2y, just dy over dx. We don't use the 2y for this one, the tabular method, dy over dx. So I'll put it like that. And when x is equal to negative 1 over 3, I also put it there. So I'll put here dy over dx. Now I'm getting the coordinates. First I'll get the 1 itself, I'll put it at the middle here. And then I'll get the negative 1 over 3, I'll put it on the middle there. We know that if we get to substitute this value in this derivative, what are we finding? We are finding a 0. Okay, we can substitute, because for us to find these two values, we equated this thing to 0. So we are finding a 0. And we know the gradient for when dy over dx is giving us 0, then the gradient or that line is going to be just straight. Now get any number very close to 1 but below and above. We can use a 2, and we can just use a number very close. So I don't want to exceed this, because we would have stepped already in another number. So this is about negative 1 over 3, something like a negative 1 over 3. Okay, negative 1 over 3, I want to get it as a decimal, sorry. So that is about 0.3. So this is negative 0.33. Okay. So when I'm getting a number close to this one, it shouldn't be much smaller than this number which is here. So what number can I get? I can get a, since that is negative 1 over 3, I can get a negative 1 over 5. This one is much more closer to 5 to 1 than this one is. In other words, you can just get any number as long as it's very close to 1. And then I'll get a number very much close to 1 but above. I can use, what number can I use? I can simply use a 2 here. Okay. So if I get a 2, I substitute in here. What will be the sign that I'm going to get? I'm only interested in the sign. So if I put 2 here, 2 squared, that is going to be 4. 4 times 3, that is going to be a 12. And then minus, if I put 2 here 2 times, so that will be a 4 minus 1. This is a negative 5. 12 minus 5, that is going to be positive. And the gradient of a positive line is like that. Okay. Now, if I get this, I substitute in this function. What am I going to get? Alright. So that is what we want to see. So that is going to become 3 negative 1 over 5 squared. That will just be 1 divided by 25. And then minus 2 multiplied by negative 1 over 5. It becomes positive because this is already positive. And that is going to be 2 over 5. And then minus a 1. So this is going to give us 3 divided by 25 plus this one. I can multiply the denominator by 5 to make it also 25. So what I do on top, I should also do down. So on top also multiply by 5. That is going to be 2 times 5, which is a 10 on top. Then down a 25. Minus 1 is the same as 25 divided by 25. So this will give us 3 plus 10, which is what? 13. 13 minus 25. The denominator is going to be 25, but 13 minus 25 is going to be negative. I'm only interested in the negative sign. So we are saying that is negative. So the gradient here is going to be what? Is going to be negative. And how do you draw a line which is negative? It's like that. So we can even see how the graph is moving here. It is going like this. So that is a minimum. Now if we come here, we can use a number slightly above negative 1 over 3. We can use a 0, it's above. And we can use a number small, like a negative 1 over, what number is going to be small? Actually, this number used here is even smaller than this one, which is here. Okay. I can use like negative 1 over 2. It is much smaller than this one. Okay, because for negative numbers, when they seem to be much bigger, then they are smaller. You can compare negative 2 and negative 1. This one is much smaller. Same with this. Whenever the denominator is much more smaller, then that means that your function is big. Okay, here the denominator is small. That means this is going to be bigger than this one, but because there's a negative attached, that means it's going to be much smaller. Hope we've gotten that. Now, if we use negative 1 over 3 itself, we are finding 0 because that is a stationary point, so that will give us 0. Now let's get to substitute 0 here and 0 here, which is this point. We're going to find a negative. So this, the line which is negative goes like this. Now if we use a negative 1 over 2, what are we going to get? A negative 1 over 2 in here. Okay. We can go on and substitute. That would be 3 negative 1 over 2 squared minus 2 negative 1 over 2 minus 1. So this will give us 3, 1 divided by 4, and then minus. So this will become positive because it's multiplying with a positive. So this and this will cancel. So that will simply be 1 and then minus 1. So this will cancel out. So we are saying that the answer we are getting here is what? Is positive. And for a positive thing, the gradient is like that. So that is how it is, and this is the maximum. Alright. So we could have used any two of those methods to get the answers. Now for C, determine the intervals where the curve y is increasing and decreasing. Well, how do we get to find the interval where the curve is increasing and where it is decreasing? So not difficult. All we are going to do is we are going to get our function. So our function is y is equal to x to the power 3 minus x to the power 2 minus x and then plus a 1. Okay, like that. Now, for this function, we've seen that the minimum is at 1 and the maximum is at that point. So getting this minimum and the maximum, we are going to get values which are slightly below and slightly above these values, and we see their behavior. So what I'm doing is, of course, we found the derivative here. Dy over dx gave us 3x squared minus 2x minus x. Okay, so when we equated this to 0, it is the one which gave us those factors. So 0 is equal to 3x squared minus 2x minus x. And to get to factorize this, it gave us x minus 1 and then x plus, that gave us 3x plus 1 being equal to 0, like that. Okay, so I'm only interested in these factors here. So I'm going to get the values of x which you found. This is simply a number line that I'm drawing here. So the smaller one is negative 1 over 3 and the bigger one is 1. And then the factors which we have here, we've got x minus 1 and then we have got 3x plus 1. Now, if we get a number below negative 1 over 3, we saw that when we equated this to 0, we found negative 1 over 3. So if I get to use any number above negative 1 over 3, this is going to give me a positive. So above, we are going to find a positive. We can actually substitute as long as we are above negative 1 over. But if we use anything less than negative 1 over 3, our value is going to be negative. And when we equated this to 0, we found 1. If we use anything above, we're going to get a positive, and anything below 1, we are going to get a negative. So because we are multiplying these two factors, let's get to multiply them. Negative times negative, that is a positive. And positive times negative, that's a negative. Positive times positive, positive. So the function is increasing where the product is positive and decreasing where it is negative. Therefore, the function is decreasing between negative 1 over 3 and 1. And then the function is increasing. Okay, it is increasing from, we can see this side and also this side. We shouldn't include these themselves because these are stationary points. So it is from negative infinity to negative 1 over 3 union from 1 to infinity. Okay, like that. Alright, now the last question is asking us to sketch the curve. Well, if we want to sketch it accurately, what I'm going to do is, of course, these are some important points that we need to have, which we've put here. So let me just put here decreasing between negative 1 over 3 comma 1 and increasing between negative infinity, negative 1 over 3 and 1 to infinity, like that. Okay, so dy over dx gave us 3x squared minus 2x minus 1, and the 2y over dx2 gave us 6x minus 2. Okay, now from here I'm going to equate the second derivative to 0. So that will be 6x minus 2 is equal to 0. 6x is going to be equal to 2 and x is going to be 1 over 3. So I'm going to now put all these points which you have found for the first derivative when we equated to 0 and the second derivative when we equated to 0. I'm going to put them like that. Okay, so now which ones are bigger? We want to write them. We have got this point, we're only using x values, and this point. So the highest is a 1. Okay, 1. And then the lowest is what? A negative 1 over 3. And then we have got a positive 1 over 3, which has come from the second derivative here. Now from here, on top I'm going to put the first derivative, that is dy over dx. Down I'm going to put a second derivative, d2y over dx2. Now, for the first derivative, we've already seen where the function is increasing and where the function is decreasing. Let me just get on and put the signs. So I've seen that between negative 1 over 3 and 1, the function is what? Decreasing. That means it's negative. So negative 1 over 3 is here, positive 1 is here. So it's going to be negative between all these regions. And above 1, we can see it's positive as we saw, and below negative 1 over 3 is also positive. Now, I'm going to come to this one. When I equated it to 0, I found what? 1 over 3. Now, if I get any number above 1 over 3, I get to substitute in here. What am I going to get? For example, I can get a 1 and put it here. We see I'm going to get a positive. So, whenever you go above, we're going to get a positive. And below, you are going to get a negative below 1 over 3. Alright, now that we have got this, from here now we can determine. So look at this function which we have. Whenever you have got dy over dx being positive, that means your line is going up. It has got a positive gradient. But when the second derivative is negative, that means it will be increasing but with a decreasing order. So it will be going like this. Whenever the second derivative is negative, that means it is a decreasing order. But if it was okay, so I'll just end on that and what I've mentioned. So it is increasing but with a decreasing order. So that is going to be like this. And then here the function is doing what? Reducing. That means the gradient is negative. So we can see that the function is reducing. And reducing is like this. And it is reducing at a decreasing order. So how is the decreasing at decreasing order? It is like this. If it is decreasing at increasing order, it would have been like that. If the second derivative was positive, it would have been like this, because it is more like wanting to go to the bigger numbers. Now, here it is also negative, but with a what? With a increasing order. It is reducing, but with an increasing order. The gradient is going to be negative, but it's supposed to go like that because it is at an increasing order. So it's like this. Now here the function is increasing with an increasing order. So increasing with an increasing order like this is different from this one, which is increasing with a reducing order, which is going like that. So this is how basically the graph is going to look like. So now we can put it down. So I've got x there, and then we have got y there. So let's put these values now on our Cartesian plane. We've got a1. Let me say this is 1 over, it looks more like a half, so 1 over 3 will be somewhere here, and then negative 1 over 3 will be somewhere here. Okay, so if we get to, we can see now how the graph is moving. We have got at negative 1 over 3. Now we found the y value already for negative 1 over 3. That gave us 32 over 27. Now 27 can go into 32 just about one time. So if this is 1, then this point will simply be slightly above 1. So it's negative 1 over 3 comma, so it will be slightly above like that. And then we have got 1 over 3. What of 1 over 3? What will be the other value? If we get to substitute in here, what will be the y value? So that is what we want to get to find. So how do you find the y value? Let's go in our function. So y is going to be equal to 1 over 3 to the power 3 minus 1 over 3 to the power 2 minus 1 over 3 plus 1. And so this is going to give us 1 over 27 minus 1 over 9 minus 1 over 3 plus 1. And this will give us 1 over 27. Let me make all the denominators the same. Multiply this by 9 on top and down. So that will be 9 over 27 minus multiply this also. Okay, this one I'm multiplying by 3, not by 9, because that's 9 times 9 will not give us 27. So I'm multiplying by 3. That will be 3 divided by 27. The one we're supposed to multiply by 9 is this one. And that will give us 9 divided by 27. And then plus 1 is the same as 27 divided by 27. Since the denominators are the same, simply subtract what is on top. 1 minus 3, that is a negative 2. Negative 2 minus 9, that is negative 11. Now 27 minus 11, that is going to be what? A 16. So that point is 16 over 27. So this one, the coordinate is 1 over 3 comma 16 divided by 27. Now 16 over 27, you can see 27 is greater than 16, so this number is going to be slightly below. Okay, that is going to be below what? Is going to be below a 1. So 1 over 3 is here, but the y value is below a 1, so you can approximate that it is there. And then you have got another coordinate here, which is 1 comma 0, so which is at this point. Now we know how the graph is moving. At negative 1 over 3 is supposed to 10, so this is where it's supposed to 10. And then at 1 is supposed to have also a minimum, so here it is supposed also to 10, like that. And then at this point it has got a point of inflation, that is where it is changing directions. So this will go more like at this point. This is where it is changing directions, point of inflection, and then it goes now up. So that is going to be the sketch of this graph. We just need to make sure that we show these points. This one is 1 over 3 comma 16 divided by 27. This is 1 comma 0, and then the maximum is negative 1 over 3 comma 32 divided by 27. This is another point that we can find when, so we can see that this is going to be a 1 actually. So this graph is going to pass at 1. So it was more supposed to pass at 1. That is when x is equal to 0. Put a 0 here, a 0 here, a 0 here. We'll see only a 1 is remaining. So that is going to be the y-intercept, a 1. So as much as it is just a sketch, it should at least make look smooth. So this is our sketch then. Thank you so much for watching. Enjoy your day.